Hello guys, in this video we are going to discuss the solution of the problem bottom view of a binary tree. So let us look at the problem statement. The problem statement says given a binary tree, return an array where elements represent the bottom view of the binary tree from left to right. Note, if there are multiple bottommost nodes for a horizontal distance from the root, then the latter one in the level order traversal is considered. For example, in the below diagram, 3 and 4 are both the bottommost nodes at a horizontal distance of 0. Here, 4 will be considered. So let us try to understand the problem statement with the help of an example. So let us say this is the tree which is given to us. The first thing which we are going to do is we are going to label these trees. So the way we are going to label is, if let us say this is my root node and this is my left child and this is my right child, then if x is the label of the root node, then the left node is at label x minus 1, or the labeling of left node will be x minus 1, and similarly the labeling of right node will be x plus 1. So with this logic, let us label all the nodes. So this is my 0th labeled node, this is minus 1, this is 1. Similarly, this is minus 2, this will be 0, this is 0, this is 2, this will be minus 1, this will be 1. And in this way, we have labeled all the nodes of the tree. So once we have labeled all the nodes of the tree, all we have to do is take the bottom view of the tree. And the way we will be able to take the bottom view is starting from leftmost and we'll go towards the rightmost. So the leftmost will have the label minus 2, and at minus 2, what is the leftmost node which I have? Well, the leftmost node is 5. At minus 1, the node I have is 10. So let's have 10 over here. At 0th labeled, so as we can see at 0th labeled, we have two nodes, 3 and 4. So out of 3 and 4, as per our question, we have to take the rightmost. Since 4 is the rightmost, so this 4 will come over here. Now moving on, the next label will be 1, and at 1th label, we have just one node. So let's have 14 over here. And then comes the second label node, and at second label node, the node which we have is 25. And in this way, this will be the output which we want to return. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So as we have discussed in the problem statement, the solution also follows the same logic, which is the first thing which we are going to do is we are going to label all these nodes, or while traversing the node, we will also keep a track on the label of the nodes. So this will be my 0th label, this minus 1, this will be 1, this is minus 2, this will be 0, this again is 0, this again is 0, this is my second label node, this is minus 1, and this is 1. And the way we are labeling it, so let us recall from our problem statement, the way we are labeling is essentially, if this is my root node and this is my left child and this is my right child, if x is the label of root node, then the label of left node will be x minus 1 and the label of right node will be x plus 1. And following this logic, we have labeled all the nodes of the binary tree. And while labeling, what we are going to do is we are going to maintain a dictionary whose key is the label. So the labels are 0, minus 2, minus 1, 0, 1 and 2. So these are the keys, and corresponding to each key, the value of the root node or value of the node is my value. So corresponding to minus 2, the value which we have is 5. Corresponding to minus 1, the value which we have is 10. Corresponding to 0, since we have to store the rightmost, so the value which it will hold is 4. Similarly, 1 will be 14 and 2 will be 25. And towards the end, all we have to do is we have to iterate on this dictionary and form a list and return our answer. And that's the whole idea behind solving this problem, folks. Now let us discuss the pseudocode of this problem. So let us say we want to do bottom view and root of the tree is given to us. So first thing which we are going to do is we are going to take an answer list, which is an empty list. And the first thing which we are going to check is if root equals to none. If it's an empty tree, then we are simply going to return answer. Otherwise, we are going to do level order traversal of the tree. So for that, we will take a queue and let's use dq over here. And within this queue, the elements which we are going to store is root of the tree, and corresponding to root, what is the index or the label. So let us say the label of the root node is 0, which is what we will start with. Once we have this, we are going to iterate on queue while length of queue is not equals to 0. And the first thing which we are going to do is we are going to pop the element from the queue. So let us pop that element queue dot pop left. And since each element of the queue consists of two values or two data pointers, one is the node of the tree and the second one is its label or index. So that is what we are going to store over here. So once we have this root and index with us, let us insert this value in the dictionary. So let us say we also have a dictionary with us. So let us do that. So dictionary of index is equals to root of data. Apart from doing this, let us maintain a start pointer, and start is equals to minimum of start and index. And initial value of start, let us say it is a positive infinity. Once we have this, now as we do it in level order traversal, let us see if root dot left exists. If root dot left exists, we are going to push this value on to our queue. So queue dot append and left child of the tree, and also since the root label is index, so the left label would be index minus 1. Similarly, if root dot right exists, then queue dot append root dot right comma index plus 1. And in this way, we will be able to perform level order traversal of the tree. And while performing level order traversal of the tree, the required information is stored in the dictionary. Now all we have to do is we have to retrieve the values from the dictionary and prepare an answer list and return to our driver code. So let us see how we will be able to extract the relevant values from the dictionary. So for that, all we have to do is for I in range of, and what is my starting point? Well, my starting point is this, and that is why we were maintaining this value. So we are going to start from start to all the way len of dictionary, and all we have to do is we have to check if I in dictionary, then answer dot append dictionary I, and towards the end we are going to return answer. So that's the pseudocode, folks. Now let us see how we have implemented this in Python. So the Python implementation is the same, folks. Over here we are starting with answer equals to an empty list, and we are checking if it is an empty tree. If it is an empty tree, then we are returning an empty list. Otherwise, we are pushing an element onto a queue, and as we have discussed, each element of the queue will contain two entries. One is the node of a tree and the second one is the label of the tree. Then we have a dictionary wherein we are going to store all the values, then a start pointer so that when we have to retrieve the values from the dictionary, we know where to start with. Then we are iterating on queue while queue is not empty, and the first thing which we are doing is we are popping the first node from the queue. This entire logic, folks, as you see, this is the level order traversal logic. So once we have popped an element from the queue, we are inserting that element in the dictionary and we are updating our start pointer or the start index. Then we are checking whether left child exists. If left child exists, then we are pushing that element on the queue, and we are also updating our label pointer, which is index minus 1. Similarly for the right child. And towards the end, we are fetching all the relevant values from the dictionary. We are populating that value into the answer list, and then we are returning it. So that's the Python implementation, folks. Now let us submit our solution. So our solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.